don't want to over-encourage you with the multiple choice nature of the test. You still have to work the problem in order to pick the right multiple choice answer, right? So you're still going to have to work the problem. It's just that there is not an infinite number of possible answers. There's just 4 answers. So that's the good part of the multiple choice. Yes, ma'am?
So, will the whole test be multiple choice? Oh.
The whole test is multiple choice.
So we'll need some.
So what?
We'll need a scan.
You won't need a scan track. You put the answers right on the test.
And how many questions are we going to look
50. Some of them you'll answer like that. Some of them you'll answer like that. So a lot of them will take you no time at all. Just recognition of something. Some of them will take you have to work a problem. And by the way, on the test day, I'm going to let you get here as quickly as the last class leave. I'll put out the test. It'll have your name on it already. There'll be an alphabetical order. A's, B's, C's, W's, and Y's. You'll find your test. Put all your stuff up front. Find your test. Get on it. Leave as soon as you're finished. Okay. So you're lucky you got the hour and 15-minute class as far as the test goes. So I encourage you, if you need extra time, show up early because you don't get it at the end. You've got a class coming in after this. Yes, sir?
Is that Tuesday or Thursday?
I'm thinking Thursday of next week. All right, that finished. Yes, ma'am. Any review we have will be on Tuesday. Hopefully we'll finish up either Thursday or part of Tuesday and have time on Tuesday to review. All right. That finishes the factoring section. So let's go to the next section, which is rational expressions. Is that the next section? Yes, that's the next section. All right. So on page 45, should you choose to look, that is the section we'll be considering. Hey, did I give you a synonym for rational? Something to think of whenever I say rational?
No.
Who said that?
Fraction?
Yes. Fraction. So if we're talking rational, we're talking about fractions. So don't be overwhelmed by the concept of rational polynomial expressions. What the heck is that? Well, it just means fractions. So rational implies fractions. So what are we talking about? We're talking about fractions, not your typical fraction like 8 over 15 or 7 over 12 or something like that. We're talking about fractions made up of polynomials over polynomials. What we're going to discover is these fractional expressions are worked, simplified, multiplied, added in the same way that we multiply, simplify, add regular old numeric fractions. So the same principles apply, just a little bit of added excitement because of the nature of the numerator and denominator. But before we should go any further, we should remind ourselves that there's one expression we cannot have involving a fraction. What is the one expression that your calculator objects to when we're talking about fractions?
Zero in the denominator.
In the denominator. Everybody know that? Zero in the denominator is a computational no-no that your calculator will remind you of every time you try to do it. Something over zero, undefined. Error. Domain error. Your calculator says. And that's exactly what we're going to bring to mind, the concept of a domain. We're going to talk about the limitations on the domain of an algebraic expression. Because the first place we encounter it is when we start looking at fractions and end up with a 0 in the denominator. That's not fun. And FYI, the domain is referring to acceptable values of the variable. I would say acceptable values of x, but hey, x isn't the only variable we use. It's the acceptable values of the variable. So when we're asking for the domain, we are basically saying, hey, what values for x can you choose? What can you choose for x in this particular expression? It's a variable. How varied can we be? What can x be in this expression? Okay, get this point. Can you listen for a second? The domain is always all real numbers, unless one of these limitations applies. Okay? The domain will always be anything. You can pick anything for x, unless one of these, and there's only two of them, one of these two limitations applies. And here's the first one. It's what we referred to. No value for x is allowed in the domain that causes the denominator to be 0. That makes sense, right? X cannot be that thing that makes the denominator 0. Don't tell me what it is, but how many of you can just look at the denominator and tell what value of x makes the denominator 0? How many of you can do that? That's good. Okay. 25% of you are willing to actually raise your hand. Probably there's another 25 who thought if I raise my hand, he might call on me and ask, what is that value? And then I don't want to do that. So I'm guessing probably half of you can look at that and tell me that what makes the denominator 0? 4, right? 2 times 4 is 8, minus 8 is 0. Some of us can see that. Some of us can't quite see it. Here's what we're going to do if we can't quite see it. If I can't quite see what makes the denominator 0, I've got a strategy, an algorithm, some steps here in order to find out what makes the denominator 0. I just set the denominator equal to 0 and solve. That's the value that makes the denominator 0. Let's do that. Take the denominator, set it equal to 0, and solve that guy. You know how to do it. Add 8 to both sides, either mentally or on your paper. 2x equals 8. Divide both sides by 2. I get x equals 4. And keep in mind the nature of what you've just discovered. You've just discovered what x cannot be. That's the one thing in the entire universe that x cannot be. So remember what I said? The domain is always all real numbers unless one of these limitations applies. And limitation number 1 does apply. There is a value of x that makes the denominator 0. You just found out what it is. X is 4. So how could you, in words, describe what the domain for this particular expression is? How could you describe that in words?
All real numbers except 4?
All real numbers except 4? Absolutely. There's your domain, ladies and gentlemen. All real numbers except 4. Typically, if we put it in a set builder notation, it would look like this. Set of all x, such that x is a real number, and x ain't 4. Okay? That's how you'd say it, set builder notation-wise. It's all the possible x's, such that x is a real number. So we're talking about all real numbers. But oh, by the way, x can't be 4. That says everything but 4.